So what I'm doing here is I'm creating an instance of a car, and I'm going to make a Honda, and then I'm going to change its value to a Volvo. Well, that's a bit silly, isn't it? In a real world, you can't just change your car. You've got to sell your car and buy a new one, that's fine. But you can't just change a Honda Accord into a Volvo because that's not the way that physics works. However, why does your code work that way? Why can I get a customer and just change its customer ID, its customer reference, the postcode? Why can I change the state of something to sold or paid for or completed or pending just by changing the property? Here, in fact, we can't. If we try and change the make of this car to a Volvo, this line won't even compile. So what we've got is compile time checking to say that we can't do anything stupid. However, we are more than capable of starting and stopping the engine of what's within this car because we've been given clean, elegant, simple, logical rules that were understood when at the time, at the best they could, at the time when it was developed and coded. The person knew an engine has the ability to start and stop. Might need in the future information about whether it's stalled, why it stalled, the petrol that was going through, whatever. But that will be an extension, and we'll talk about that in a second. So here we're not able to do anything silly with our DTOs. They're no longer DTOs, right? They become rich objects that implement and have business logic in them and stop you from making changes. So records are extendable. You can change a record either by having access to the record yourself, and you can update that code. But of course, you can also use extension methods. Extension methods, if you don't know, are just truly amazing. In fact, if you're doing anything in .NET Core, you'll have used extension methods every single day. They're just everywhere now. The ability to add and decorate functionality on top of a pre-existing object without the need to change that object, which is kind of solid, kind of clean. There are downsides to it, but of course, if used well, it's a very powerful tool. Here we can see, and just squint because of the syntax, I've not created a class that's static or whatever, it's just a method. But here we can see we've got a static string, get full name. It's an extension method to the person, and it gets passed in a person object, of course. And therefore, we're able to return first name and last name. Now, getting the full name actually is quite tricky. If they have a middle name, if the first name is empty, do you trim it? If there's hyphens and apostrophes, do you make sure that they're localed? So actually just outputting a dear salutation is harder than you think. But we're not getting into that. What we can see here is I've been able to extend the person object. Even though I might not have access to it directly, I can actually extend and add a method to it. So now I can run me, Gary Taylor, and full name, and I can get the full name. If I see if I have a coding example, so my keyboard wakes up. So get full name. Let's see if I can find that. So here we've got a person record. We run that, and we are able to output the full name. We can see there we get Gary Taylor outputted. So that is pretty good. We've been able to extend and add methods onto it. Note though, even with extension methods, you're still not able to actually change that object. So if you looked before and you saw it, well done, you can see an int call count. And what I wanted to do, it's a bit silly, but what I wanted to do was every time we called get full name, just increment the counter. so we know how many times it's been called in code. However, that won't work. It won't even compile because once again, it's immutable, even within an extension method, because an extension method isn't in the context of that class object. It's not in that code. Therefore, it's still not got the permissions to actually make a change to that object, like status could with a car. And we were able to change it to running or to stopped. Now, if we put all this together, what we can do is we can have enum for case statuses. So imagine you're selling financial products, you're selling future stock, you're selling a secured loan, a mortgage, things like that. So here we've got a case, which is a customer. We've got a secured case and we've got a mortgage case, and each case has got a status. Where it is it new, has it been sold, is it a particular lender, whatever. But this is your business domain context. We're able to very, very quickly create a abstract case, which you shouldn't be able to make an instance of. We've then got a secured case and a mortgage case, which inherits from case. So now we have the ability to have a customer who has a financial product attached to them that's got a status. So here I'm just creating an array of them, just creating a couple just for testing. Then a helper method just to get them, iterate through them and yield them out one by one, just to show this yielding process. And then an easy print method. But the meat then becomes in something like this. And I'll see if I can flick to code in a second just to highlight this. But what we're able to do is we're able to make a parameter check, a pattern matching check, sorry. We're able to actually look at a record and say, right, you're a secured case, so do this. You're a mortgage case with a particular status, so do this. And you are a mortgage case without that status, so do that. Now, if you've ever been in a meeting where your product owner is saying, if this and that, or this, and if you're in this, then we need to do this. You know, the famous, if you have eggs, buy, 5, and the guy comes back with nothing because there was no eggs. That type of thing. You're able to construct up your business logic, but using pattern matching and record types, you're able to do this in a very, very, very clean way. So let's see if I can find the coding example for this. So as we can see, if I just run this again, 1000, 2, 1000, 3, 1000, 4, 1000, what we've got is we've got data being streamed in. Each one of these data items is a case object of a particular type. So for instance, one is a secured case at new. One is a mortgage case at search. One is a mortgage case at search still. Another mortgage case at completed. And what we're able to do is we can stream through all of this so that we're using little amounts of memory. We're not holding up any processes. We can do all this asynchronously. And we can pass this to a pattern matcher that says, if we are a secured case, I want you to say we've found a secured case. And of course, this is where your business logic would be, or a call to your business logic. If we're a mortgage case that is at completed, then I want you to say I've found a mortgage case. And if we're just a mortgage case and it's not completed, then I want you to just say I've found a mortgage case. And we can see when we call this, loop through this and send it to the check case, we're printing this out and we can see we've found a secured deal. We found a mortgage case, found a mortgage case, we found a mortgage case. And this was able to go through this relatively complex logic, and note that this can really get big and can explain a lot of deeply complex stuff in a really clean way by utilizing records that are of certain types. And that is very, very, very powerful. So let's flip back now, if we can, to the next section. And that we just talk about this and what it is. The next section now is validation. So unfortunately, when developers get rushed and when there's a lot of work to do, effort isn't put into making a domain as clean and elegant and as validated as humanly possible. And I get it. I've been on that side where I've just had to bash out code because a feature needs to get pushed out into production, and that's life. Now, with the use of records, we can add validation to records very, very, very quickly. We can change them very quickly. A lot of the boilerplate code, as we've seen here, is removed. So this is an amazing way now to be able to sprinkle validation into our DTOs. And we now can add methods and extensions that make our DTOs rich. And we can now add validation to make them even richer. So let's have a look. I just like this one. I think I've got your SDK errors with a generic invalid argument when I send my birthday as 13th of the 35th, 119878. Developer just turns around and says, my brain hurts. And that's because vast majority of systems just allow data to be injected into them. Surnames can be null. Dates of birth can be in the wrong format or just completely incorrect. Business validation rules can just be bypassed. And that's because we haven't had time to put validation into these DTOs or even our domains. So let's see how we can actually protect this. So give yourself time to think about, why would you allow your model to be in a bad state? Well, I know it's probably time, but we should never allow that. For instance, the Volvo should never, the Honda, sorry, should never be allowed to be changed to a Honda. That's just basic validation by using immutability, but we can go a step further than this. So let's say we've got this class with an address of house number and postcode, and we've got a person object with first name, surname, and a list of addresses. Sounds pretty easy, right? But then the product owner might say, well, the surname can't be null ever. We must always have at least one address, and that address has to be the residential where the person lives. We've got to have at least 3 years worth. So if we haven't got 3 years in the current residential, we now need to add more addresses. Otherwise, it's not valid. The postcodes need to be UK postcode validated rules, and they can't be null. And addresses cannot be deleted. You cannot just delete an address. We need to mark an address as deleted, but that still needs to be held in memory, still needs to be held in a database. We need to know if someone added an address and then just deleted it. And lots of other business rules related to it. That now becomes problematic. How do we stop someone from deleting an item from within a list when that list has a delete method? How do we stop people from sending in null surnames and things? How do we make sure that it's a certain length? All of that now means that your class has got to add more validation to it. With records, because the code is is more simplified, is got a lot of syntax sugar around it. What we can do is we can actually pass in, say, a guard clause. And here I'm using a library, which is the guard clause library here. And it's a NuGet package. Of course, you don't have to use it. You can just write your own if you wanted to. But I really like this NuGet package. I think it's pretty clean and simple. And here what we're doing is we're saying when we create a person object, we want to guard against the surname being null or empty. So when we construct this person object, if we was to pass in a null or an empty string, we would actually get an error when it runs. So we would get a runtime error, which would be nicely formatted, and we would get that. Now that means we get an error, but it also means that we don't get an object in an invalid state. So a saying that I like is make a legal state unrepresentable. You can't do it. There's no way you can do it. You cannot get a person with a null surname or an empty string surname. It's impossible. Bear with me, nothing's impossible. But you've guarded against that. And you've done that by adding validation directly into that record when it's being instantiated. And here we can see, because we are guarding against the surname, we've needed to construct that property argument and pass in a declaration there that checks it. Because of that, we've now have to initialize that property. So here we've got a person which is going to have or has a list of addresses. And here we can do person name, but here we can do remove at. And this works, unfortunately. This has the ability to remove that address. So that's something to just have a bit of a think about. So one of the ways that we can guard against this even further and to make things a little bit easier to deal with is to create builder patterns. Now, once again, .NET Core, you should be familiar with builder patterns, but whenever you're writing code, if you ever do a new something, there are better ways to do it. I was going to say you're doing it wrong, but that's a bit too opinionated. But you really want to be thinking about a different way of doing that. Instantiating objects, not using dependency injection, not using a builder pattern, you're going to put yourself into a really bad state as your code gets bigger and bigger. So what we're able to do is we're able to use constructor methods. So here I've got a method called create, which just returns a person object. What we're able to do is passing our first name and surname, but once again, guard against that property. Now, this means that within this record type, I've not had to create my own properties. All of that auto-generated code has been done for me. All that syntactical sugar has been done. I now have person object with first name and surname, but I've not had to instantiate or create, them properties. Because what I've done is I've used a constructor, which will a custom constructor called create, which is like a factory pattern or a builder pattern. So instead of new, I am doing person create. And that means because I'm using that, I have got the ability to add these guard clauses, and therefore I would get an error at runtime when we hit this. Once again, never allowing bad state to be representable. So we've got then builders and we've got constructors. So what's best? Do we get them to find out? Well, no, a lot of it is down to personal preference. I like the builder patterns because I like that. I think it makes for cleaner code. But if we have a look here, we've got a record with a constructor. We've got first name and surname and age. We're guarding against the surname. We're guarding against it being too long. We've now had to pass in the values because we didn't declare them within the record type. And now this almost looks like a class. So is this great? I'm not too sure. If we then hoist them values so that the first name and age is in the person object, I didn't have to put them into the constructor, which means I don't need to have created the properties. I only need to create the properties for the thing that I'm guarding against within this constructor, which is a little bit better, but realistically, what doesn't have validation? What kind of data have you got that literally is a absolute free-for-all? In fact, it could be any length, like 1 billion characters long, and it'll still save. Something somewhere has to give, right? So almost everything needs some form of validation. So this is okay. You can hoist the things that you don't care about to the top, and then you can just guard against the things that you need and instantiate them within the constructor. So that's okay. Now, if we throw all of this together, that's when the power of records really becomes to shine. We have the ability to create the properties, to create all the boilerplate code, to create a constructor which will have guards against it for, being empty or too long, and all the details that the product owner has asked you to validate against. We can then create a new instance of this person, passing it in and putting it out. But then values could possibly still be null, and the person calling it that's using your record might not know this. So I like to use a thing called optional types or optionals, where you declare whether something is nullable or has a particular object. And you can use things like has a value. And you might have seen this with nullable types, where you have the ability to say, has this got a value? And then you can say, if this has value, then display it, otherwise set a default. And you can always do null coalescing and other sorts of things, but I like the optional type. What we're able to do here is we're able to say that it's possible for the middle name and the last name to be null. Even though we're guarding against it, still technically possible. So we need to make sure that our callers are aware of that. If they just blindly go and use the full name, or worse, address, an address is an array which is nullable, then you're going to have a bad day because you're going to get an object reference exception. But with this, what we're able to do is we're able to guard against the value being passed in, but we're also able to help the caller guard against it. So here what we're saying is that the middle name and last name could potentially be null, and it's up to you, Mr. Caller, Mr. Developer, to deal with it. Well, in this scenario where we've got a dear salutation, and I told you dear salutations are tricky, we have a middle name, and that middle name could be null. So we've decided that if middle name has a value, we're going to print its value out, but we're also going to print out a comma. Otherwise, we have decided that it's correct to just output an empty string in this scenario. That's what the business thinks is correct. That's what we decided. So when we print the full name, we're able to print the first name, the middle name, the last name. But if the last name is null, we're going to output unknown. Bit odd, but that's the way that this business wants it, right? So now when we output this, we get a value which is similar to Gary, Peter, comma, Taylor, because we passed in Peter as a middle name, and it's used this matching expression to produce this variable. We not only have guarded against it being wrong within the constructor, within the default builder, we have also told the caller that it's still technically possible for this to be null. Now, do we feel safe? Do we feel good? Do we think that everything is okay at this point in time? Well, unfortunately, there are still problems that are being worked on. And one of this is that the with clause can bypass all of your validation. So for instance, in this scenario, what we've done is we've used the with on you to change the last name to be null. And then when we print it, we can see that the last name is in fact none. But what we've done here in this scenario is we've still protected the developer because we have used optional types, which means that the developer has had to use options non-string, and when outputting, they get an optional object, which has a value of none, which means that the developer then has to do a thing like, have you got a value, or output a default. So in this scenario, you would never get a null outputted, you would never use a null, but it's now down to the developer to work out what to do with that state. Is that non-representable? Have we put our code into a horrific problem? That's up to you to review. So there's optional types there, and there's also Zoran, which is brilliant. There's all the videos and things. So I hope you've really enjoyed this. There's also going to be a link to this documentation with the sample code so you can go through it. I think you'll find that records now are more than just DTOs. I think you'll find that you can extend these things now. You can add more functionality. You can use them as like a real boy, as a real class, as a real unit of work. If you've got a domain or a context, or if you're adding extra things to it, extra functionality, you can do that. But also you can validate, you can clean up, and you can make it represent business state, which is really, really powerful. These aren't just simple DTLs. These aren't just things that hold data that you just pass from model to model. These are things that can truly represent your business logic and work as domain objects, so that all of your complex if, else, switch state, branching conditions can all be represented as types. Hope you liked it. Drop us a comment, and hopefully you can click that like button. If you like this and you want more, let me know.